Hello and welcome to this section of the MATLAB tutor. Here we're going to continue working with vectors and specifically just introduce a few simple functions. None of them are complicated, but things that you might occasionally use to operate on vectors or when you later on construct your MATLAB programs that you may use to operate on vectors in the context of a program. So try to keep that in mind when we introduce some of these pretty simple functions. They're not so much something you do on a homework assignment. It's something you might use when you code MATLAB to perform a function. So this is all in the context of vectors. So let's go ahead and set up a vector. Let's call it R. And the vector can have, any number of elements. Let's say we'll do 1, 3, -4, 8, something like that. All right. So we've defined a vector. It tells us the R vector has 4 elements, and the 4 elements are labeled there. And the first thing we want to talk about is you can tell by looking at this vector that it has 1, 2, 3, 4 elements. All right, you know this. But if you're writing a program and you're doing mathematical operations on a vector, maybe you're not sure, maybe your code does not know ahead of time how many elements are in a vector. So if you ever need to figure out how many elements are in a vector without you actually counting them on the screen, you just use the function length. Length in the context of MATLAB means how many elements. So you just say length, pass it the vector R, and MATLAB will tell you this vector has length 4. All right. If you create a new vector, something like this, with many more elements, and you tell it, okay, let's find the length of S, then it'll tell you have 7 elements in the vector S. 1, 2, 3, 4, 5, 6, 7. There you go. All right. Let me clear the screen. The next thing you might have an occasion to use would be if you have some vectors. Maybe you want to know, vectors are long strings of numbers. We've already exposed the fact that vectors dealing with, x, y, z in terms of physics, that's what we typically use vectors for early on. But the broader definition of vectors is just a giant list of numbers, one singular list of numbers. It could be the grades in a classroom. It could be the height of your students in centimeters. Maybe you have 50 students, so you might put that in a vector, which is just a listing of numbers. So you might want to know what is the minimum value in this list of numbers. So you might say, all right, I'll take the minimum value of S. Right? So vector S, let's find the minimum value. It'll go search through that vector and it'll tell you the minimum value is 3. If you notice, we can actually see the value of the vector here, and you can see that 3 is indeed the smallest value. You can find the maximum value of a vector by the same sort of thing. You just look at vector x, find the maximum value. The maximum is 32. And notice if we do minimum on vector r, right, the other vector, it'll find -4 as the minimum value. Of course, it understands negative and positive numbers. That is the smallest value, right, to the left on the number line, basically. And again, these are simple functions that you may say, well, I would really not use this, but you never know. I mean, you need to think of the broader context of MATLAB. In all of these cases, I'm defining these vectors. I'm typing them in, like this vector here, I just typed it in, on the keyboard. But maybe you're using MATLAB as part of a statistical analysis of some data file or something that you're importing, because later on I'll show you how to do that. You can actually use MATLAB to if you might have a giant database of I don't know, IQ of a bunch of people in the world or something, but there's like 3,000 elements and they're just listing one number after another. So you wouldn't type that in. You'd have that in some external data file that you would import into MATLAB, and we can show you how to do that a little bit later. You can pull that data in. So then maybe you might want to find the minimum value of that data file that you put in. Maybe you'd like to find that maximum value of whatever it is you pulled in, just to quickly pull out some essential facts. And so you need to sort of think about it in that context. All right. The other thing that you might have occasion to want to use to operate on a vector would be the sum. Maybe you have like I said, some information about lots of people. Maybe you import a data file or something and you pull it into a vector. So you would use the sum operator, and notice it's trying to tell you that you can go ahead and you can put a vector here in for the argument. So if we do the sum of r, those are all the elements in vector r. What it's going to do is it's going to add all these things together. So 8 plus a -4 plus 3 plus 1 is going to basically give you 8. And so it just takes the sum. So the sum of S, same sort of thing. It just adds everything together. So just quick little mathematical things you might have occasion to need. Now let me show you this. You might use that, for instance, if you wanted to find the average value of all of the elements in vector S, right? Maybe vector S represents, how many centimeters tall, some plants are that you go measure in the field or something, 3 centimeters, 4 centimeters, 5 centimeters. This one's 32 centimeters. Maybe you want to find what is the average value, right? So one way to do that would be to take the sum of elements in S, and then that result, you just divide it by, what do you think you would divide it by? Well, you need to divide by how many elements you have. Now we have 1, 2, 3, 4, 5, 6, 7 elements, right? So we can take the sum of those elements, divide by 7, and we get an average value of 8 overall. However, there's an easier way to do it, because what if this vector was huge? What if you imported this from a database and there was like 300 elements, but you weren't sure exactly how many? Then you would take the sum of the elements in vector S, and you would divide it by the length of vector S. So this is the sum of all the elements divided by how many elements we have. That's what length is. We talked about that a minute ago, and you get a value of 8. So these little simple functions can come in handy for things that you might actually need to do. Now, it turns out I'm showing you this for, to illustrate what you might use sum and length actually for, but it turns out that there actually is a function called mean that does the same thing. You can operate on any vector and calculate the mean of the elements. Basically, it's doing the same stuff behind the scenes, and you get a value of 8. So whether you choose to use the mean function or do it manually or whatever is up to you.